Complete the multiplication problems. Number 1a, 2n to the third times 6n to the fifth. And if we expand out these exponents, 2n to the third is the same thing as 2 times n times n times n. The next term would expand out to 6 times n written down 5 times. We can multiply in any order. So if we put the two numbers together and then all the same variable letters, then we get 2 times 6, which equals 12, and n times 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 n gives us n to a final power that is equal to the number of times that n is written up here, which is 8. In the next problem, 1b, we have 2n to the third, and all of this expression to the third power, which means that we are multiplying 2n to the third a total of 3 times. 2n to the third times 2n to the third times 2n to the third. That's what the 3 means. 1, 2, 3. And now if we expand out each one of these terms, 2 times 2 times 2, times 3 sets of 3 n's, giving us a final product of 8 times n to the 9th power, because there are 3 sets of 3 n's. I'll give you a moment to complete the multiplication problems for problem 2a and 2b. Let's check your answer. 5a squared times 3a to the 4 equals 15, and a to the 6th power. Problem 2b, 5a squared to the 3rd power equals 125, and a to the 6th power. Students, you already know that exponents represent repeated multiplication. In problem A, notice that the final power of the variable is the same as the addition of the two original powers. N to the 8, 8 is the same as 3 plus 5. A to the 6, 6 is the same as 2 plus 4. In problem B, notice that our final power of the variable is the same as the multiplication of the two original powers. N to the 9th power, 9 is the same as 3 times 3. A to the 6th power, 6 is the same as 2 times 3. In this lesson, we will use these patterns as exponent rules to multiply.